Welcome to the Steep Dive. Today, we're exploring something really fascinating, how technology, maybe even tech you have at home, could totally reshape stroke recovery.
Yeah, we're looking at some compelling research suggesting, get this, that many stroke patients might actually be getting, well, underdosed in their rehab.
That's right. And the solution might lie in personalized, at-home therapy using video games.
So our mission today, to unpack how a new method turns simple movements in these games into really valuable personalized data that shows us these insights.
Exactly. And, virtual rehab using games, it's already known to be basically as good as traditional therapy. Plus, it's often way more motivating for patients.
Okay, that makes sense. More engaging, maybe?
Definitely more engaging. But the big hurdle has been figuring out what to do with all the movement data you get, especially from, low-cost systems like Kinect used at home where things aren't controlled like in a clinic.
Right, so it's like there's just too much noise. How do you find the actual therapy and all that? Precisely. It's like searching for a needle in a haystack. You need to filter out all the background noise to find the movements that actually count as therapy.
Okay, let's break this down.
Yeah.
So picture this. You're recovering from a stroke, playing a game, maybe Recovery Rapids on a Kinect. How does the system tell if you're doing the therapy movement or, I don't know, just reaching for your water bottle?
This is where the really interesting stuff happens. This methodology we're looking at today, it's like a super smart data detective. It's a six-step process.
Here's these apps. Okay.
First up, it has to clean the raw data. Think of it like tidying up a messy room. It gets rid of glitches like duplicate data points, missing bits, weird spikes maybe caused by furniture or something, using smart filters. Then it chops up the continuous gameplay into actual therapy sessions so it knows when you're really doing the exercises versus just taking a break or pausing the game.
Got it. So cleaning first, then identifying the therapy time. What's next? How does it filter out like those random movements you mentioned, the non-therapy stuff?
Right. That's step three. And it's crucial. It uses this clever algorithm, DBS scan it's called. Think of it like a bouncer at a club.
Okay.
It looks for patterns, it groups similar movements together, and more importantly, it kicks out the movements that don't fit the pattern of a therapeutic exercise.
So it can tell the difference between, say, an elbow exercise and maybe you just waving your hand while talking.
Exactly that. Or even someone else walking past in the background. It analyzes specific things, kinematic features, like your trunk angle, how your torso is positioned, things like that to make that distinction.
That is pretty clever. Okay, so the noise is gone, the random movements are out. How does it then figure out what specific therapy movements you actually did?
Good question. So the next step is identifying the specific therapeutic gestures. These are the movements designed to trigger actions in the game.
Ah, like steering the boat in Recovery Rapids.
Precisely. Maybe that involves, say, shoulder abduction combined with elbow extension. And the system is smart enough to recognize these gestures, even if your movement isn't perfectly normal because of the stroke's effects. It accounts for those individual differences.
Okay, so it identifies the intended therapy movement. But what about quality? Does it measure how well you did it?
Yes, exactly. That leads to the next step. There's something called a normal C-shape index, N-shape for short. It basically scores how closely your actual movement matches an ideal path or trajectory for that exercise.
So it filters out sloppy or incomplete movements.
Right. If you only did half the movement or mixed it with something else, the N-shape score would be low and it might get filtered out. It ensures we're only looking at properly formed movements. For example, they found a threshold of 0.70 worked well for a raise arm movement.
Okay, makes sense. And the final step brings it all together.
It does. It calculates a kinematic normalcy index, or inequality of movement. This combines everything relevant speed, range of motion, smoothness, and crucially, it looks for any compensatory movements, like shrugging your shoulder when you should be using your arm.
So it's one single score reflecting the overall quality.
A single comprehensive score. And this is powerful because it allows for within-patient analysis. You can track your specific progress over time, see improvements, maybe even spot when you're hitting a plateau. It's truly personalized.
And this wasn't just a theoretical exercise, right? This was tested.
Oh, yes. Validated with 24 stroke survivors using that Recovery Rapids game. And the results were pretty compelling.
What did they find?
Well, first, after all that cleaning and filtering, about 71% of the raw data was still kept for analysis. So plenty of good data left.
Okay.
And crucially, that inequality of movement score we talked about, It lined up really well with standard clinical tests, things like the Wolf Motor Function Test, and also with how patients felt they were using their arm, based on something called the motor activity log.
So it actually reflects real-world function.
It does. But here's something really fascinating. The data showed that most patients were still improving throughout the study period. Their dose response plots kept going up.
Wait, so they could have potentially done more therapy.
That's the strong suggestion.
Hmm.
It points towards the idea that maybe current standard rehabilitation protocols are actually underdosing therapy for many people. And it also really highlighted how different everyone's recovery path is.
Which underlines the need for this kind of personalized approach.
Absolutely. It shows the immense value of tailoring treatment plans based on detailed individual data.
Wow. So this deep dive really shows how these sophisticated computer models can take something pretty common, like a video game, and unlock incredibly personalized insights for rehab. It feels like a real game changer.
It really does. And it makes you think, doesn't it?
Okay.
If we can measure and quantify rehab movements at home with this level of detail, what else could we apply this kind of analysis to?
That's a great question. You could imagine using it for, like, optimizing athletic training, maybe? Or tracking fitness goals with amazing accuracy.
Or even personalizing just daily routines for better health. The possibilities seem huge.
Definitely something for you to mull over until our next deep dive.